Welcome back. We are ready for the next session of speeches, actually only 2 remaining. But before going into that, remember to open the ROS project. Now the link is there, so you can see here the button, here, yes, there, yeah. So press on the button right now so you can get the ROS project for the next speaker ready. And in the meantime that it opens,
Control is telling me that we have some more interesting hashtag ROSDevDay images. So let's have a look. Yeah.
I know this guy.
I know that guy.
Yes.
Marcus Vinicius.
Marcus, how you doing, man?
Wow, that's a good setup, huh?
Yeah,
2 screens.
awesome.
I think 2 screens.
Yes, it's the main.
It's the sweet spot, yeah.
Yes.
There's
But also he's living in the mirror world. You see?
oh, that's true.
Yes,
that's true.
the letters, they are kind of mirrored.
Or maybe we are in the mirror world.
Oh, yes, of course. Yes, it could be that also. We don't know.
Let's see.
Or
another
maybe also it's a possibility that we've been here too many hours already and we are...
Yeah. Oh, too much coffee.
Oh, too much coffee.
But
Yeah.
Starbucks coffee, the best one in the world.
Starbucks.
It's not sponsored by Starbucks,
No.
by the way.
Starbucks.
Starbucks. Yeah.
Bots.
Let's see the next one.
Yeah.
Okay, this is by Hassan Hussein Harir. And it seems a big screen
Yes.
with 2 browsers open in parallel.
Exactly.
Nice.
So he can see the different parts divided into different, like if he's kind of emulating that he has 2 screens, right?
Yeah.
With one single screen.
Okay.
Great,
More?
interesting.
And another one from Marco Pedretti. And
he has a ROS developer t-shirt.
from last year.
Is it?
Yeah,
Sure.
it's the last year cup.
Oh, and
See?
okay. So he's one of the winners of the last year.
Wow.
Oh, awesome. Okay, so you're applying for another one, right?
Sure. Each year.
Yeah, each year. Okay. Very good. Very good.
Okay. Now.
Any more?
It
Not
seems
more
that,
so far?
yeah. Okay.
Keep posting. So still we haven't decided the best one. So you can keep posting
Until
until the end.
Till the end. So we love them. We really do.
Yes. Yes, that's the alarm.
So
You have to take the pill, right?
Yeah. Which one? Which one? Okay. So let's continue now with the next speaker hitting the stage. It's Dominik Nowak. Dominik is the CEO of Husarnet and the CTO of Husarnet.
Yes, and Husarnet is a system for doing VPNs in a secure way, but it's more than a VPN, so it's another concept. It's like a VPN, and that allows us to connect remote computers in a secure way, and especially we can use this for ROS robots. So Dominik today is going to talk about how to use Husarnet for connecting a remote gazebo simulation with your local computer. So let's see what Dominik has to say. Hello, Dominik, are you ready?
Hello, guys. Yes, I'm ready. It's great to be here.
Our pleasure. So if you're ready, can you share your screen, please?
Yes,
Because we can see you now. Okay. We got it. Very good.
Okay.
There it is. Perfect. So the audience is all yours, Dominik.
Okay, perfect. So let's start. So at the beginning, let's discuss about the aim of this of my presentation. So we are going to connect RVs running in the ROS project together with the gazebo simulation running locally on your laptops. And interesting part is that everything runs in Docker, and I will present with you a good tips about how to run containers, how to run Docker containers with ROS, and how to connect them over the internet the right way. So guys, let's start then. To realize that instruction, you need to have Docker and Docker Compose pre-installed. So here's a quick instruction how to do that on Ubuntu. There are, of course, similar instructions for other platforms like Windows or Mac, but I strongly prefer Ubuntu, so basically Linux to run Docker, because if you run Docker in Windows or Mac, it doesn't your containers doesn't work, let's say, natively on your platform, but in a kind of virtual machine that is between Windows operating system and your container. So from performance point of view, use Docker and Docker Compose on Linux, not on other platforms. You of course can do it, but due to performance, Linux is better. So let's start by cloning the GitHub repository I have created for this presentation. So let's go there. Okay. So basically, the same instruction that you can see here in my ROS project is also here in the README. So you can follow also this one. So let's just clone this GitHub repository. Okay, then let's open Visual Studio Code. Okay, so before running the system, let's take a look at the project structure. As you can see, I have got a couple of Docker Compose configurations here. Not only one Docker Compose file, but multiple of them. And for those of you that are not familiar with Docker and with using Docker with ROS, Docker is basically a container. Is a way to run your software that is shipped together with the configuration. So if you have your ROS2 setup Dockerized, everybody that has only Docker installed on their system can run your container, and there are no any other additional requirement regarding your system. So just Docker needs to be present on the host OS, and that's all. You can run and distribute your ROS or any other kind of software very, very easily. So from the DevOps perspective, it's a good way to run software in Docker. And Docker Compose is a way to launch multiple containers at once, because this is a very good practice to divide your ROS2 setup into multiple small Docker containers that do one thing, but do that one things well. So this is why let's take a look at this compose.gazebo.yaml file. And in this compose.gazebo YAML file, we launch two containers. The first one is with this Gazebo simulation of ROS.XL. ROS.XL is our new robot. I will show you this robot very, very soon. And we also run here a nav2 container, so container with navigation to stack. And of course, we also added our own configuration to both to ROS.XL and to nav2. And thanks to that approach, you can launch the same container in multiple robots. And the only thing you need to change is a configuration that is applied to the container. So the first task is to just launch everything. So the first thing we need to do is to give permissions for our containers to gain access to our visual environment. Okay. And right now, let's launch the setup totally locally. So right now we will control gazebo simulation from RVs running in a single on the single computer. Okay, so everything is starting right now. Oh. So a gazebo needs more than 1 minute to start. With new gazebo, previously known as ignition, it starts much faster. But we are in the process of moving the project, the simulation model of our robot to new version of gazebo. Right now, this is the older version named currently Gazebo Classic or something like that. And as you can see, we launched not only one compose.yaml file, but two of them. So there is compose RVs YAML and compose gazebo YAML. By using two separate files in a single Docker compose command, we launch Docker compose combines those two files into a single file. So thanks to that, you can divide your high-level system configuration into separate units, and then you can decide whether you would like to launch them together or separately. And please note also that we use here Docker Compose v2. You can easily find that this Docker Compose file v2, not v1, because of lack of dash here. So as you can see, gazebo needs some time, but let's be patient. Only the first run takes so long. And Ricardo, can I maybe can you share the image from my web camera? I can maybe show. Oh, just launched. Okay. Oh, everything has started.
Yes.
Yes. Okay. Okay. So let's scroll down. As you can see, there is a robot running in the gazebo simulation on the left, and RVs on the right. And together with gazebo simulation, also nav2 is present there, so we can order the robot to go somewhere. So let's select the 2D goalpost. As you can see, the robot is driving. And this robot is our newest product that we will launch in the following months. It's called ROSbot XL. And after my presentation, I can show you how it looks like in real life, because it's standing here near me right now. So as you can see, we have just launched everything on the single machine. But the goal of this presentation is to present you how to control robot that is operating on remote machine, that is running, on remote in remote site. So maybe you can control your robot this way, that is 200 kilometers away from you. So I will show you in the next step how to achieve that. So let's go to the second task. And right now I will tell you what to do to connect this gazebo simulation and RVs over the internet. Of course, right now I will run those two setups on the single machine, but totally the same procedure might be for running both gazebo and RVs on separate computers. So instruction is totally the same, and it will work totally the same. To connect our robots and RVs over the internet, we need to log into husarnet.com app. Okay. And we need to create a new VPN network in which our gazebo simulation RVs will be running. So let's name it ROS Dev Day 22. Okay. And only thing we need to get from this web dashboard is so-called Husarnet join code. Join code is this long line, the long string that allows you to connect your devices to this specific VPN network. And we apply join code to our system, but using .env file with environment variable with Husarnet join code as environment variable. Okay, so let's just copy this Husarnet join code and paste it here. Okay, that's all. Right now we can launch our system over the VPN. This was the only step. But no, wait, there is one additional step. We need to launch this little script that is present in this repository. And what this script does is generating IPv6 addresses used internally by Husarnet VPN and paste them in the custom DDS configuration file. Okay, because you know, when we connect our devices over the internet, we no longer can use the default DDS discovery mechanism based on multicasting, and this is why we need to use a custom DDS config file. Here we are using a fast DDS config file, and in this config file we need to present addresses for devices we would like to connect. It is, let's say, to run that project faster, instead of using host name, we are using IPv6 addresses from the specific Husarnet devices we will launch. This is what this simple script does. So it is generating Husarnet IPv6 addresses and ID for each devices, and replace this host name with IPv6 address. Oh, sorry. Oh, as you can see here. Okay. Okay, so let's launch our containers. So at first we need to stop. Oh, okay, here it is. Okay, we need to close the existing containers that are already running in our system, and let's launch these two separate setups. So let's start with Gazebo. As you can see, we launch the same compose.gazebo.yaml file as before, right? Oh, this is the same file as here, but we launch it together with the separate configuration file for Gazebo. This configuration file launches Husarnet VPN network, of course, in the container, and I will show you how it looks like in a minute. So let's launch it. Okay, and while our simulation is starting, let's take a look how this gazebo.husarnet.yaml file looks like. Okay, as you can see, we added. So maybe let's open two separate files. Okay. Okay, in gazebo.yaml file, we launch the basic definition of ROS XL container that is running our gazebo simulation. And to make possible to connect to this gazebo simulation over the internet, we need to apply additional configuration that is present in this gazebo.husarnet.yaml file. And we need to start with network mode with Husarnet namespace, because we are launching a separate container with Husarnet VPN here. And we need to place our Docker containers in the same network namespace as this Husarnet Gazebo container. And by doing that, we share network interface created by Husarnet VPN to those containers. Under volume section, we add our custom DDS configuration I mentioned before. And we also need to point on the DDS implementation we want to use in our project. Because this container is based on ROS2 Galactic, and when in ROS2 Galactic, Cyclone DDS is a default DDS, and for this project we replaced the Cyclone with Fast DDS, and if you want to use other DDS than default one, we need to create environment variable pointing on the right implementation of ROS middleware. And also we need to apply our custom DDS config also to this environment variable. Okay, as you can see, our gazebo simulation has just started. It looks totally the same, right? And let's go back to the Husarnet dashboard and refresh the window. And as you can see, our gazebo simulation is now online. Okay, so let's open a separate window and let's run RV's containers the same way. Okay. Okay, we need to wait a little bit. Okay, here we go. Here it is. And as you can see, that the system looks totally the same. But as mentioned before, we can launch those two Docker Compose setups on separate computer operating on different continents, and it will work totally the same. So the robot is driving, everything works fine. Okay, so now it's time to connect to control this gazebo simulation, not from a level of this containerized setup, but from a level of ROS Development Studio. So let's go back to our instruction. And right now we will launch the setup inside of ROS DS. So let's launch RVs in ROS.ds. So the first step is to start Husarnet here. Because we will not use Docker container based setup on ROS.ds. I will show you how to connect native ROS2 system to the existing Husarnet network, also with ROS2 nodes working there, but in Docker. So the first step is to open the shell. And let's start Husarnet daemon. Okay, we need to do that because in ROS.ds there is no systemd. And this is why we need to start Husarnet daemon manually. Normally, if you would install Husarnet on your own laptop, Husarnet would work in the background. It would start automatically. But if your system is not equipped with systemd, you need to launch Husarnet manually, like here. Okay, so let's open a separate window. And now let's connect our ROS.ds environment to our Husarnet network. So let's refresh. Oh, as you can see, we have Gazebo and RVs here. Everything is online. So let's connect our ROS.ds environment also to this network. So husarnet.join command. Then let's paste the join code and let's name it ROS.ds. Okay, joining, done. Okay, let's refresh. Okay, so ROS.ds, RVs, and Gazebo are in the same network. So the next step is to install FastDDS because this ROS.ds environment is based on ROS2 Galactic, where FastDDS is not installed. So let's just install FastDDS.
Dominik, I think you're muted. We can't hear you. In the Hangouts, can you have a look at your Hangouts? Yeah, I think at the bottom, there's icons there.
Oh.
There you go.
Okay. So some kind of shortcut probably. Okay, so right now we need to create a custom DDS configuration file for our ROS.ds environment. So to do so, let's open a code editor. Okay, code editor. And let's copy the content of the DDS configuration file that we already have working on our local environment. So it is under secret folder. So let's just copy the content of this file into ROS.ds. Okay. And we need to add the IPv6 address of our ROS.ds environment. So we need to add this IPv6 address to that file. So let's copy it. Okay. And as you can see, the same IPv6 address needs to be present in 3 different locations in this file. Okay. And the last one. Okay, so custom DDS config is there. Nice. Okay. So the next step is to add RV's configuration file from config folder. There is a configuration for RVs that we need to copy and paste into the ROS.ds environment. So let's open code editor. And we need to create RVs2 folder with default RVs file. So code editor. Okay, new folder .rvs2. Okay. Probably folders with dot at the beginning are not visible here, so we need to change it. So file, preferences, open settings. Okay, let's just copy this line and it should work. Okay, now we can see hidden folders, and our RVs2 folder is also here. We need to create a file named default.rvs. New file default.rvs. Okay. And let's copy and paste the content of the RVs here. Okay, and finally, the last step. The last step is to launch RVs directly with inside ROS.ds with our custom DDS config applied. So to do so, we need just to launch that line, basically. As you can see, the similar situation as in our Docker containers. So we also need to point to ROS middleware implementation and path to our custom DDS config file. And then we just run RVs. That's all. Okay.
Thank you very much, Dominik.
We need to wait a little bit.
For what?
Okay, and in a couple of seconds, we should see our RVs running in the ROS-DS, okay?
Yes, we still have time.
Okay, as you can see, now we can control our gazebo simulation not only from our local computer, but also from ROS-DS. So let's go here. Let's open our gazebo simulation. And as you can see, you can now control this robot over the internet from ROS-DS. So thank you guys. Basically, this is all. And also, this is of course only a basic configuration with DDS. There are also more advanced and maybe smarter methods of connecting robots over the internet with our VPN. But this is maybe the simpler one, the most basic. But also I need to tell you about very interesting projects that are described in our blog posts. So the first one is a DDS router, so the project by Eprosima, and the second one is a discovery server. If you would like to see how to run the same project, the same configuration with using those technologies, all you need to do is to switch the branch, because as you can see in our GitHub repository, we have a couple of different branches. And the same setup, but working with DDS router is present in the DDS branch, basically. Okay, guys, that's all. Thank you.
Thank you, Dominik. Thank you very, very much.
Thank you.
Okay, so for the audience, as always, you can pose your questions in the tab for questions, ask the speaker, and vote for the questions that you like the most.
Exactly. And in the meantime, that people is posting questions there, decide for the questions. Let me ask you one of myself, Dominik. So you have shown here the setup for the control of ROS1 based simulation, or is it so? Is the system applicable to the control of ROS1 and ROS2 based simulations, both of them, or is only for one of the types?
So you can mix the ROS2 and ROS1 systems together if you want, thanks to ROS bridge. But of course, for ROS1 systems, there is no DDS config files.
Mm-hmm.
But instead of that, you need to point on ROS master by using its IPv6 address or Husarnet hostname. And I have also created a GitHub repository where you can see how to connect ROS1 Docker containers, ROS1 based Docker containers over the internet. And this repo is called ROS1 Docker Listener. So that's our favorite Docker Listener demo with ROS1, but working over the internet. And also everything is in Docker. And as you can see, we need to define those environment variables for ROS1 Docker containers to make it possible to work over the internet with Husarnet VPN.
Yeah, okay. So one thing is, can you share this link with maybe with Alberto on the chat? So Alberto will send with the chat to the audience. So that will be interesting for them.
Yes.
And then
so
also,
here is Husarnet setup for ROS1 and for Docker.
Okay. So now Alberto will post it for everyone on the chat of the conference. Mm-hmm. And then also, so what it means is that for ROS1 is even simpler than the example that we have seen here for ROS2.
Yeah, it's a little bit simpler. However, while using DDS router and discovery server, also this setup would be much simpler. Because of the fact that by using those two technologies, you do not need to modify the custom XML file while you are adding another robot to the fleet. So you have the same config file for fleet consisting 2 robots and 100 robots. So this is why you need to do only one, let's say, configuration, and it works the same in the fleet of any size.
Yes, it's a shame that we didn't have the time to prepare. Because so Dominik wanted to show us especially this, but it was required a lot more work to prepare everything. And we did, so finally the conference was here and we couldn't show, but you have the links that Dominik has shared, and then you can go through those links and try to do it yourself.
Yeah, and you can also read more about those two ROS2 technologies that I mentioned. So VDS router and discovery server in my blog post. I just shared them with Alberto in the chat.
Fantastic. So more questions. So we have one here from Rodrigo Gonzalez. He asks, will Husarnet's ROS2 connection need Cyclone DDS to be configured now that the default is fast DDS?
No, Husarnet basically works with any DDS implementation. So as you can see, even in this demo, there is even in my demo there is a Cyclone DDS branch where you can see the same setup but with Cyclone DDS. But of course, fast DDS is a different one in ROS2 Humble. So this is why I decided to present on fast DDS, not on Cyclone.
Great.
Yes, and then Ruben Alves is asking, so in this demo you were controlling the simulation in the cloud, but it could be, actually you can apply the same setup that you did here to control anything like other computers, right?
Yeah. This is the case. So I just created that setup for the simulation model because everyone can easily reproduce my system behavior without having the physical robot. But basically the same configuration would work also for physical systems. And not only for ROS or ROS2, but for any of them, because Husarnet is a special kind of VPN, and VPN creates simply a virtual network interface, allowing you to allowing any of your, let's say, apps talking over this network interface, not only ROS or ROS2. But of course, we designed Husarnet with ROS in mind. And this is why it has some special features like low latency connection, like being lightweight, like working out of the box with DDS and things like that.
Fantastic. Okay. And I have a question here, half question, from Brian Merritt. He says, how do we get early bird discount on the ROSbot XL? So I suppose he's asking when to see the robot, and also
when you release it,
the
final release, if there is any discount or any discount that you can provide to the audience.
Yeah. We are going to make a pre-order campaign for our robots, starting probably in 1 month on the beginning or autumn. So can you share the image from my web camera, Ricardo? I will show you how this robot looks like.
Yeah, we're looking at it right now. Yeah. Yes.
Okay.
Can you show us?
Okay. So here is.
We lost you.
Oh.
Completely. So the camera went down completely, but we can hear you.
Okay. How to?
Yeah.
Okay.
Yes. Can you?
Give
No,
me a
not
moment.
yet.
Give me a moment.
Yeah, sure. Probably
Camera is
disconnected
off.
the cable.
Disconnected or something.
Yes, camera is off. What is going off?
Maybe disconnected. Maybe you need to go to settings and reselect it again because of the movement. Something. Yes, looks like it's coming back or something. Is doing. Oh, or you are gone completely. Yeah. So we have lost Dominik in the cyberspace, and here he comes back.
There we go. There we go.
Yes.
Wow.
We cannot hear you, Dominik, but we can see your ROS bot and the ROS bot XL.
Oh, that's nice. With omnidirectional wheels. And it seems a beast. Seems like, I don't know, like maybe a 10 or 20% increase in size.
Yes, awesome. And also looks nicer. Yeah, so we cannot hear you, Dominik. I don't know if you are talking something.
I think you're
muted. You are muted again.
You're muted again in the Hangouts.
Computer.
If you go there in the Hangouts.
Cannot hear you yet. No. Muted.
Yet. Oh,
there
better?
There you go.
Now. Yeah.
Okay, perfect then. So yeah, this Robot XL is a little bit bigger, is much prettier, and has much more space for your own equipment on top of that, has much more powerful computer options inside, and is based totally on ROS2. So even microcontroller code is based on micro ROS. And of course, the whole micro ROS firmware will be open sourced. So this is one of the world first totally 100% ROS2 based robot.
Awesome. So in 1 month, right? You mentioned?
Yes, in 1 month. And of course, there will be discounts in the pre-order campaign.
Okay. So it's answer the question. And let me ask this question because you know the answer. So Hassan Hariri is asking, is this the same way we are connecting to the Construct Remote Lab? I mean, Husarnet.
Yeah. So yes, in your remote lab, Husarnet is also used. So you guys have some kind of experience in using that technology, and I hope my presentation will show you also, let's say, more advanced setups and ways to improve your robotic fleet operating over the internet.
Great. More questions. We have more questions. You are not done yet, Dominik. You are not done.
So we have Maladinaga Subhash. Could you please suggest some more applications and uses of connecting ROS2 nodes running on remote computers?
So there are a couple of them. So let's talk about the simplest one. So just let's say remote access to your robot, so you can control your robots remotely over the internet with low latency. So thanks to that, you can think about telepresence applications. You can also create distributed robotic fleets combining mobile robots, drones, and each of your robots in the fleet can be connected different way to the internet. So some of your robots could be connected over Wi-Fi, some of them over Ethernet, and drones probably over LTE or 5G. And you can think about your robot network, robot system as it would be connected to the one virtual network, to the one virtual router. And everything is done thanks to Husarnet VPN that just allows you to connect remote robots into the single system. And thanks to that, your robotic fleet can operate more can operate simply better, because now you can think about your system as a whole fleet, not as a group of individual robots, and you need to find a way to communicate your robots over the internet, over cloud, over API, over anything. Thanks to Husarnet, you can just communicate the robots over the internet natively by using robot operating system. And I think this is the greatest things about that, because it simplifies your architecture, basically.
Okay, so let me ask you a final question about the time, but I think it's interesting, this one. So Danuts says, have you tried to identify whether geographic location has a larger influence on the latency in Husarnet?
Could you rephrase?
Yes, sure. So if you have done any measurement about in which locations of the world the Husarnet is producing more latency, or has larger latency or lower latency, if there is any study that you have done to measure latency in different parts of the world using Husarnet.
Oh, this is a very good question, because even in the same city, you can have latency like 10 milliseconds and 100 milliseconds. Everything depends on the internet link of a specific end device. But if internet link is strong, then I will give you example. So one of our clients is in Canada, and we are let's say developing a software for this Canada-based client, and often we need to test something from our lab, from our office, so to launch RVs and to control robot in Canada from RVs working in the laptop in Krakow in Poland, and we have latencies like 50 milliseconds or even less. So you feel like the robot is standing next to you, basically.
Yeah. Okay, great. Well, we have more questions, but we have to finish here because it's already time. Then thank you again, Dominik.
Thank you.
Thank you, guys.
Take care.
Okay. Bye.
Okay, so thanks a lot. And now you'll see a box here appear in somewhere where you'll have to rate the speaker, Dominik in this case. Please do so. And we will announce the best speaker of ROS Dev Day 2022 in a very short time.
Yes, so very short time. And now we have to prepare for the next speaker. And for that, remember that you have to go to the Docs tab. After you have rated the previous one, you have rated Dominik, then you can go to the Docs tab and then open the project. If you are watching in the other window, then just look at here. You can see the button is the same. It depends on which screen you are.
And while we wait, we will see another quiz video. In this case, it's sponsored again by us, The Construct. And it's a video about Carla Simulator, maybe? Yes. Yeah, so it will work in the same way. You go, you see the video, and at the end, there will be a question, and the one that answers the question faster, it will get what it will get?
This amazing T-shirt of the conference, and also this amazing mug. Okay, you cannot see very well, so I don't know how to do this, but well, it has the same design.
It's a deep sea effect.
Yes, probably. Yes.
Okay, so we will put the video, and we will see you in around 5 minutes.
Let's go. welcome back. So, a different question, right? Yes, I know, it was an easy one. Yes. We don't want to put you in a difficult situation. We just want you to win a t-shirt like this and a mug like this one. So the correct answer, of course, is Unreal Engine, and the winner is Stefan Nesser. Congratulations, Stefan.